Hello friends, welcome you all. So in this video we will discuss how to create grammar for some context-free languages. So as you know friends, all context-free grammar can generate context-free languages as well as regular languages. So regular languages we have already seen, and now we will take some example context-free languages and we will create grammar for all these languages. So I have listed some language here. So for all these languages we will generate context-free grammar. So we will start with first language an b to the power n, where n is greater than or equal to 1. So as you know friend, here the value of n is greater than or equal to 1. So it means the minimum string of this language would be ab. So this language is not accepting epsilon. So in this case we cannot have epsilon transition for star symbol. We can create one grammar there. The star symbol will be as there. Now one more thing here, as we as we need to have equal number of a and b both, so both a and b must be generated in the same production rules. Otherwise we cannot have any control on number of occurrences of a and b. So it is necessary to have both a and b generated in the same production. So I can have like a s b, like this, a s b. Now a s b or a b. So now this is the grammar for that particular language. Now you can see here in both the production we are generating a single a, then we are also generating single b. So suppose if we have only value of n is equal to 1, so we can use this this production. So any string from this language can be generated through this grammar. So this is context free grammar for this particular language. So I hope it would be clear. Now I will take another language and we generate the grammar. So an b to the power 2n, where n is greater than or equal to 1. So now you can see my friend, if we have a and double number of occurrences of b, then how we can do this? Again, in as in this example, how many a we are generating, in the same number of b we are generating in the same production. So the same logic we can use here also. So I can have as gives a s b b, and if n is minimum value of n is 1, so I can use here a b b as single transition. So now this particular grammar can generate all strings from this language, And now one more thing, my friend. Here, both these grammar are not accepting epsilon. So this is the grammar. Now suppose if both these grammar are accepting epsilon, then in this case the value of n would be greater than or equal to 0. So if the value of n is 0, then it will also accept epsilon. So what change you need to do here? Only either you can add one more production here as gives epsilon, here also as gives epsilon, or what you can do, you can remove this production, and you can remove this production. In place of this production you can use only epsilon, because this string can be generated by putting s as epsilon in this particular production. So you can have both these production, or you can remove this production and you can only have epsilon here. So both will be correct, no problem is there. Now ideally this must be removed from here and epsilon will be there only as a production. So the corrected grammar would be a s b b epsilon. So this would be generating all strings of this particular language. So I hope it would be very much clear. Now I will take third language as example, A to N B N, where N is greater than or equal to 1. Now here we have third language as A to N B to Bn, where N is greater than or equal to 1. So again we can use the same logic here as gives A S B and A B. So this would be the grammar for this particular language. So it is very much simple. Now next language we can have as an bm b to the power m c to the power n, where both m and n are greater than or equal to 1. So now in this particular language we can have minimum string as a b c, because both m and n will be having at least 1. So now you can see we have to make a relation between a number of occurrences of A and number of occurrences of C. So we need to make sure then if we are generating A in any production, then we will also generate one C in the same production. So I can use it like this. You can as gives A S C. Now one more production is there possible, A C. This is also possible. Now, through this, we can have any number of A and C together. The same number of A would be there and same number of C would be there, as long as we are using this production only. Now, we can create B from this production. We can create from this production. Now, on B, we are not having any condition. The only condition is B must be, at least one occurrence of B must be there. So what we can do, we can create any number of B from this production and simply we can replace this A with B. So this would be creating B and these two productions will be creating A and C both. So you can see whenever we are generating A, we are also generating C. Here also, here also. Now on B, we are not having any condition, so we can create any number of B's there. So we can have productions like this. So I hope this is the grammar for this particular language. So I hope it would be very much clear. Now I will take next language as example. So I can have AN, BN, CM, DM, where M and N both are greater than or equal to 1. So now again we can start from S. Now you can see, my friend, we have to create a relation between the number of occurrences of A and number of occurrences of B, as well as number of occurrences of C and number of occurrences of D. So we need to make sure when we are generating A, then we must also generate B in the same production. Similarly, when we are generating C, we must also generate one D in the same production. But you can see we have these A and B side by AB and CD side by side. So what we can do here, we can have as gives AB like this. Now we can write production of A as A, capital A, B and AB, and the production of B as small c, capital B, small d and C, D. So this production will ensure at least one occurrence of A and B, and this production will ensure at least one occurrence of C and D, and this production will ensure A, B and C, D are side by side. So this is how you can create grammar for this particular language. So I hope it would be very much clear. Now you can have different condition of M and N both. Suppose both are 0 greater than or equal to 0. So both these production will be converted into epsilon. both these production will be converted into epsilon, and if both are 0, then this will also be 0. So there would be, you can also include one more production here, epsilon, but if you are converting these two production in epsilon, then it will be correct. Now if m is greater than 0, greater than or equal to 0, and n is greater than or equal to 1. So here we must have at least one occurrence of CD. So in this case, this can be converted to epsilon, this can be converted to epsilon. Now if you are having at least one occurrence of AB, but you can have zero occurrence of CD, so in this case, this will be converted to epsilon. This will be converted to epsilon. So in this case, you can create grammar for any particular any language of this family. This is how you can write grammar for any context free language. Now I will take one more example, the last grammar as last language as example, and I will show you how to create language for this. Now this is the language for which we need to create context free grammar. Now you can see, my friend, there is again we have there are four variables. We have a, b, c, and d. Now this time we have relation between a and d as well as b and c. And now in this time these variables are not side by side, but they are inside, one pair is inside another pair of symbols. So now how we can generate this particular grammar language for using any grammar? So I can start with s again, which is star symbol. Then I need to make sure whenever we are creating A, then we will also create one D there. And if we are creating B, then we will also create one C there. So I can write it like this. So A, S, D, A, S, D. Now I can have any number of A and D with this production. Now to create B and C, I can have one more production here as A, D, A, D. Now, this particular variable A we can use to create B and C. So now I can have production of A as, now with the help of A, we are creating B and C. So this must be like this. If we are creating one B, so we must also create one C. And this production will ensure at least one occurrence of B and C. As this particular language is not generating epsilon, so this would be the grammar which is epsilon production free grammar. So this is how you can create grammar for this kind of languages. Now you can see, if we have both m and n as greater than or equal to 0. So in this case, it will generate epsilon also. In this case, it will generate epsilon also. So I can have one production here, epsilon production, right? So I'm telling you the different condition. So in this case, if this both m and n are greater than or equal to 0, then you can add one epsilon production with s. Now, if m is greater than or equal to 0, but n is greater than or equal to 1, it is like this. So B and C may be epsilon also, maybe epsilon also. So that in that case, here this production can be replaced with epsilon production. This production can be replaced with epsilon production, right? Now if you have m is greater than or equal to 1 and n is greater than or equal to 0, so what you can do in this case, now in this case you can replace this production with single a. with single A only, so that you will not create any occurrence of A and D. So this, in this way, you can make sure you can control the number of occurrences of A and A, B, C, and D. So this is how you can create corresponding context-free grammar for any language. So I hope, friend, it would be very much clear. And if you have any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you. Thank you so much.